Hi guys, welcome to Unity Insights, a dedicated channel for beginners focused on teaching Unity. For our new viewers, myself Somnath Chaudhary and I'm a professional Unity developer. Today we'll explore another very useful component, Rigidbody2D. If you are planning for physics-based 2D game or your 2D game requires physics-based interaction, then you might need to use Rigidbody2D. So let's jump into the Unity editor and understand its properties. Like rigid body video, here also I have created one small environment to demonstrate the rigid body 2D properties. So here I have a background with sprite renderer and it's rendering this image. Now I have one empty game object and inside that I have multiple different game objects to demonstrate these properties. So here the first one is body type. Let's enable it. So here I have created, okay, let me open it, one base which is the base of this area. Here I have a sprite renderer and a box 2D, okay, box collider 2D. I have a left slope, I have a right slope, okay, so here also all same, right slope also it's the same, sprite renderer, box collider 2D. I have two empty points, right? So point A and point B, so that I can move this platform to from point A to point B. Okay, and here in this platform I have a sprite renderer. Here I have attached a rigid body and here body type is kinematic. Next I have a box which is this green color box. Here also I have a sprite renderer, box collider 2D, rigid body 2D. Here body type is dynamic. Now I have two circles, one is big and another is small. So big one is dynamic and a circle collider I have attached here, and here I have a sprite render, right? And for the small one, similarly, this one the body type is static, circle collider, and a sprite render. Okay. So now in body type we get three options: dynamic, kinematic, static. Dynamic means whenever you need full physics simulation, you can use this dynamic option, right? For this example, I have made this big circle as body type dynamic. Similarly, for this box also body type dynamic. But I have used this platform as is kinematic, right? So kinematic object, whichever is body type is kinematic, that object through script you can give animation. Okay? Here I have attached a script where I'm saying like this object will move from point A to point B. Okay, and the movement speed is I mentioned here. That's it. So let's play and see what happens. So here two balls. So this one is static, this one is dynamic, and this one is also dynamic, and this one is kinematic. Okay, it's taking little all time. Okay, it's almost done. Okay, it took really long time. Okay, now you can see this green box is fallen on this platform. The big football fallen from here, right? Because these two are dynamic, the green box and this football. This one is kinematic, that's why I'm able to move it. And this one is static, that means it will hold a static position. Now the question comes, when we should use this different options, right? So for example, this static, this small ball, it is static, right? But it acts as a static item, like immovable item. But can I move it with script? So let me attach the script here. So I have the script here which says move platform, right? So let me attach it and I can give a point A, point B. So what will happen? This also will start moving along with this platform, but physics engine won't expect that. As you mentioned this as static object, but you are moving it, that means your CPU calculation will be more. So this is what you should not do, because in your game you know which all objects are movable and which all are immovable, right? Now you can see this football is going to that point A, point B, and it will start moving to that point. But we should not do that. For any object which is movable, we should make it as kinematic, and then you can move the object with script. Okay, let me remove the script here. So another question comes, what would be the use of then static? If it is static object, then why should we use that, right? So here in static object, you can use the triggers. So for example, I have this left slope, right? Here I want to know, like, whenever this football is touching this left slope, I need to know, right? So for example, if you have a player who can jump, right? So whenever he is in mid air, you cannot press the jump, you cannot jump again, right? Whenever he is grounded, that time you can jump. So to get to know whether the player is touching the ground or not, in those cases you can use this static type of object, right? So for this left slope, I have created one script here. So just I'm checking on collision enter, on collision stay, on collision exit, and I'm just printing the values, right? And now let me just attach the script here and let's play. So now whenever this big football will touch this left slope, it should give me a log, right? Now let's stop it and let's see here. Now you can see the big circle big, it entered, stay and exit. So to get to know whether your object is touching any static object or not, that time you can use this static type of what you call trigger, right? Okay, so that's one. That's how we can use this body type. Now let's disable it. And now next one is material. So for material, what you can do, for example, this big football we have, and here is the next property is material. So as of now, we don't have any material, which is physics material 2D. How we can create that? Right click here under asset, under create, go to 2D, and then you can create the physics material 2D. Here you get different options like fraction, bounciness, friction combine, and bounce combine. There are 4 options. So let me take the platform, which is Kinematic, and attach it here, right? Or okay, let's remove it. Let's see for the bounciness. Let me, as of now, the bounciness is 0. So let's take the big football and connect it here and see what happens. So as the bounciness is 0, it should not bounce here. Okay, now you can see there's no bounciness effect here. But whenever I change this material bounciness, let's give it to 0.5 something. Let's see. So I have changed the value here, and that material is used in this big football. Now you can see it's like giving a bounce effect. Okay, and now we can remove this one from here, and we'll see for this platform. Now I'll use this in the platform, and here what I'll change, let's make the bounciness 0 again, or you can make it 0.5, doesn't matter, but we'll change the friction. Let's make it as 0. So what was happening, this square was falling down and it was moving along with the platform. Now when I made the fraction 0, that means there is no fraction effect should come. That means this big square should not give any movement. See, now it is like in the static position because fraction is 0. Now let's change the fraction little bit. It was like 0.4. Let's make it 0.4, same with the default value. Now you can see it is moving along with the platform, the big square. And if I make it even more, let's make it 1 and then see what happens. Now you can see the movement is even. That means the more fraction, that means the more thick movement it should have. Okay, it won't have any much sliding effect. Okay, so this is how you can use your material. Let's disable the material, and now next we'll see the simulated. So for this simulated, it will act as like the static here, right? So here I have the simulated checkbox, right? Even though my object type is dynamic, I have turned off this simulated option. That means there is no physics calculation here. Even the trigger also will not calculate. Even it's getting triggered by something, that also will not have any effect. Okay, so here we have turned off this checkbox simulated, but for this big football I have turned it on, and the small one also it is turned on, but it is static type. That's why you are not seeing any other properties. Okay. So now this big square, it should not fall, it should be in the static position because we have turned off the simulated checkbox off. Okay, you can see it is static position. So when we should use this, like whenever you have a um, uh, whenever you want to go for a ghost mode, like your player will not, if it touches the enemy, even though it will not have any effect, right? It's like a god mode, you can say. So in those cases you can use this is simulated. Or sometime for object pulling, like if your object is somewhere outside your painting drawing, and based on your requirement you can drawing on the screen and then making the is simulated turn on, so that it will have the physics effect again. So that is called, instead of destroying the object again and again, you can keep it outside of the screen and again change the position in the screen. So in that way you can use the simulated effect. Next is use full kinematic contact. So let's understand this. So here what I made, so whenever my box is moving, right? So here for my box, not box, sorry, my platform, right? Here, where is that? Let me reduce it. I have made the use full kinematic contact, this checkbox on, and similarly for the small. Okay, so there is no, as it is static, there won't be any is simulated option, right? But what we can do now, let's see. As of now, you can see whenever any object, right? Okay, let it play, then I can tell you what's happening. Now, whenever this platform is touching this football, like the small one, you can see there is a contact here, right? Now, if I turn this off, like this platform, if I turn this use full kinematic contact, that means it will not tell the small football that anything is touching there. Let's play once again. Okay. Now, whenever it's touching, there's no contact here. So you can use this feature to check whether any object is having any contact with your object or not. Like this small football, is any object is getting contacted or not. Okay. So this is useful kinematic. Now next is use auto mask. Let's turn on this one. And now use auto mask for this big football. Okay. Let's turn this one off and make this auto mask as 1. Okay. Sorry, this mask as 1. And for the small one, let's again turn this one off and let's make it as 10. So whichever has higher mass, that object will push the other object, like whichever has lower mass. So now let's see. As of now, we'll remember the small one has a higher mass and the big football has a lower mass. So what happens whenever you play, the small one should push the big one because the small one has higher mass. Now you can see the small one is pushing the big one here. Now, if you don't know how exactly the mask should be for this game object, just turn it on this checkbox so that Unity will calculate how much based on the collider size and the object size. Unity will collider how much the mass should be. Okay. So for this big football, you can see the mass is now 3.01 something, some value. And for the small one, if by default we made it 10, okay, manually, but if we turn it on, now the value is 0.75 something based on the size and the collider. Okay, so this is how you can use the auto mass. Now next is mass. You must have already understood the mass concept here. Now in this time I have made the big football mass as 10 and small football mass as maybe let's say 1. Okay, now let's see with the higher mass how it pushes the small ball. Okay, now let's okay, now you can see the big football is pushing the small one because the small one has lower mass. Now the mass value can be 0. No, it cannot be. If you press 0 and enter, you can see some value 0.001 value, right? So with this like value, like the lowest value, if we play, what happens? The big one will push the small one like with super higher force. See, it gone somewhere outside. So this is how you can use the mass concept. Next is linear dumping. We have already explained this concept in our rigid body, but again I'll try to explain once again. So here we have 5 different footballs, small footballs, and each one has different linear dumping value. Let's say the first one is 0, second one is 1, like all other values are same except this linear dumping, right? 2, 3 and 4. So whichever has higher linear dumping, that object will fall slower, right? Like it's like the parachute effect, like it will fall slowly. So let's play and see with the higher value how it falls. You can see whichever has higher value is falling slowly. This is why you can use the linear dumping. Next is angular dumping. So for angular dumping, let's say for the big football, angular dumping by default value, I think it's 1. Let's see. Okay, angular dumping value is 0.05. So let's make it 0.05 and then let's play. Now you can see how much it is going. It's going somewhere till here. Right? Now let's stop it and change the angular dumping value to somewhere 5 or something. Whatever you want, you can enter the value and check which one is best fitting for your game or application. So for this angular dumping with higher value, it will not go that far. See, after sliding, it's not going that far. Here only it got stopped. Okay, that means the angular dumping it's affecting, not to rotate that much, not to travel that much. You can say. Okay, let's revert back to default value, and then I'll turn this one off. Next is gravity. I think it is the simplest concept here. So here also I have taken again the 5 different footballs, and this time we different gravity scale. For the first one, the gravity scale is 0.1 with a minus value, minus 0.1. Second one I made 0, then 1, 2 and 3. So whichever has minus value, that one will go toward up. That means like anti-gravity toward upside. Whichever has 0, that will remain in that position like static, and remaining 3 will fall based on the gravity scale. So that means whichever has higher gravity, that will fall first, then the next one, then the next one. Let's play and see once again. See, this one fallen first, then this one, then this one, and this one, the first one had minus value, so it gone toward up. That's how gravity you can use. Next is sleeping mode. For sleeping mode, okay, let's take the small one. So for sleeping mode, gravity scale. Okay, for this collision detection, I have already explained this concept in rigid body video. If you want, you can go and check that video for detailed demo. But overall, I'll tell you, whenever it is discrete, a fast moving object collision might not detect, right? And whenever it is continuous, even though if it is fast moving, it will continuously detect the collision. That simple it is. Okay. Now we are next we'll check for sleeping mode. So for sleeping mode, you get three options. One is never sleep, one is start awake, and one is start asleep. For this small one, I made it start asleep. Okay. For big one, it is start awake. Okay. So as of now, let's see. So that means this object will remain in that position until any external force comes and touches this object, the small one. Okay. That means start asleep. So whenever your game starts, it will be in sleeping mode until any external force comes and gives it a shake, you can say. So let's play and see. So this small football should be there until this big football comes and touches this small one. You can see whenever the big football came and touched this the small one, then it got your uh, from sleeping mode to now it is awake mode, right? Now let's change it to, instead of start sleep, the small one, we'll change it to never sleep. Okay, so that means this sleeping mode will be always awake. So whenever you are in start awake or start asleep, then this sleeping mode would be sleep sleep until any external, until it stops or something. Okay, so let's play once again and see what happening in this awake state, I can say. Okay, so now let's go down once again. See the sleeping state, it is awake. Okay, and these are keep moving slowly. So until, even though if it stops completely, right, but still some calculation will keep happening, right? Like if I make, okay, okay, now this big football, okay, let's see the big football. Now you can see it is asleep mode, right? But the small one, it's still awake mode. And if I make the rotation maybe zero something, uh, okay, that's not the correct thing. Okay, now you can see it is stop mode. Here position and rotation all are like stop, but here it is still awake mode, right? So that's how what it does. It never sleep means it is always in awake mode. Okay, so this is how we understood sleeping mode. And the final one is constraint. So for constraint, so for this big football, okay, let's turn this one off. We get two position x and y and one rotation for z. So for this football, big one, let's first freeze the x position. Okay, that means this red side, it is x, right? Red side, it should not change position. So whenever it falls, it will be in that position only. See, no, it fallen there and there's no x position change. Okay, and now if we freeze the y position, that means it will be in that position, it will not fall. Okay, so let's see, if my y position is freezed, this object will not fall. You can see the box and other things are moving and all, but this big football, it's not changing y position. And now the final one is your freeze rotation. Now if I turn this one on, what will happen, this football will fall and it will slide, it will not have a rotation effect. You can see there's no rotation for this football because of this freeze rotation. So whenever you need a sliding effect, that time you can use this z freeze rotation, right? Okay, so now we understood all of this. And now next is layer override, that also I have covered in our rigid body video. You can go and have a look. And this info section um, you can consider as an information to get the information of that game object, right? And you can utilize this information for your game. That's it in this video. Thank you for your time and patience. Hopefully, you got some insights about Unity's rigid body 2D. Now you can play around with different values and see which all are best fitting for your game or application. For any doubt or question, please comment down below or send me your query via email, which is displaying on the screen. Also, I would recommend to join the Unity Insights WhatsApp channel and share your queries there. See you in the next video. Till then, keep learning.